Okay, question number 2. The length of aluminium baking foil in a roll may be modelled by a normal distribution with mean 91 metres and standard deviation 0.8. Probably what I do in working a solution to this is write down a summary of that information to start with. So it's a normal distribution, the mean is 91 and the standard deviation is 0.8. So in writing it in this form, we always write the variance 0.8 squared, and I'm going to use that in my calculations later. The first question asks me to determine the probability that the length of foil on a particular roll is less than 90 metres. Even though most of you are going to use a graphics calculator for this, I absolutely advise you to draw the distribution. So there's 91. 90 is less than 91, and we're looking for the probability that we're actually less than 90, which is there. That immediately suggests to me that the probability is going to be less than 0.5, and I'm now going to use the graphics calculator to help me with this question. So as all of you are going to be familiar, I'm going to just make sure that everything's off the screen. I'm going to press NCD. I'm then going to do my lower value, which is going to be minus 9999, comma, then it's the upper bound, which is 90, then it's going to be my standard deviation, which is 0.8, and then it's going to be the mean, which is 91. You can close the brackets if you feel that you'd like to there, and then I'm going to execute. And the probability of that happening is 0.106. Remember, answers should be given to 3 significant figures. And for completeness here, I'm just going to write down what I actually keyed into the calculator. Another little piece of advice here is I'd strongly advise you to check very carefully. I summarised my information here as to whether or not you were given the standard deviation or the variance. In this case, it was the standard deviation. That's part 1. And there's my answer, and I'll make that clear by underlining it. Part number 2 asks me for not exactly 90 metres. Well, we know for a normal distribution that the probability that we have an exact value is 0. Therefore, the probability that we have not an exact value is 1. So that's a cheap mark there that you need to spot and should be fine. Part 3, really, if we're good with the graphics calculator, is no more difficult than a part 1. This time it asked me between 91 and 92.5 metres. So again, I'm going to draw my distribution. I'm going to draw the mean at 91, and it asks me to find the probability that it's been between 91 and 92.5. And I'm going to shade that in. On the last part of the question, I actually did it the wrong way around. I'd always advocate, again, writing down what you want to put into the calculator and then enter it into the calculator. So let's do it right this time. So the lower bound is 91, the upper bound is 92.5, the standard deviation is 0.8, and the mean is 91. So historically, those people that were using tables for this, there would be a nice way of finding the Z value here. You'd know that that was 0.5, and that would work out quite nicely. But again, I would imagine that most of you are going to be using the calculator and following the method that I've just adopted there. So again, I'll clear the last piece of information. I'm back to NCD on the calculator. The lower value is 91. The upper value is 92.5. The standard deviation is 0.8, and the mean is 91, and that gives me a probability of 0.4696. Now, you wouldn't be penalised for leaving it like that, but for 3 significant figures there, that one's going to be 0.470, and I'll underline my answer there. Okay. That concludes part A. Part B is a de-standardising question. The length of cling film on a roll may also be modelled by a normal distribution, but with mean 153 metres and standard deviation sigma metres. It's required that 1% of rolls of cling film should have a length less than 150 metres. Find the value of sigma that's needed to satisfy the requirement. There's a very good section in the textbook to help you with this, and indeed students who went through historically would probably have a better comprehension of this problem because they're well used to using the formula x minus mu over sigma in order to find their z value and hence to use the tables to solve the problem. We've been using the calculator back here and our LUSM function and NCD to find probability values, but this is what we're going to be using in this question. So this time I'm told that the distribution has a mean of 153, but the standard deviation is unknown. I can draw that so it's centred on 153. The other piece of information that I'm told is it's required that 1% of rolls of cling film should have a length less than 150. It's required that 1% of rolls should have a length less than 150. Read those parts very, very carefully and make sure that you get the probability on the right side. So I want 1% of my values to be less than 150, and that's going to enable me to find out my value of sigma later on in the question. So what I now do is I use my statistical tables to find out what the z value would be that left 1% or 0.01 down in that lower tail. So I go to the normal distribution page in the tables, and I actually want table 4. In table 4 the probabilities are on the outside and the z values are on the inside. I want 0.99. Now 0.99 gives me a value of 2.3263. I'll just hold that so you can see in the camera, 2.3263, but that would be up here, leaving 99% of the distribution on the left-hand side. So this value is minus 2.3263 from the symmetry of the normal distribution curve. Now, I'd get that z value by using the formula that I showed you at the top, x minus mu over sigma. So z is also equal to, well, I've got the x value, that's 150. I've got the mean value, that's 153. What I don't know is sigma. And what I do is I equate these two. So I'm going to say 150 minus 153 over sigma is equal to minus 2.3263. I'm now going to multiply both sides by sigma. At the same time I might just do this calculation. So 150 minus 153 is minus 3. And times by sigma, and on this side I'm going to have minus 2.3263 lots of sigma. What I'm now going to do is I'm going to divide both sides by minus 2.3263, and I'll need the calculator for that. So sigma is equal to minus 3 divided by minus 2.3263, and this is going to enable me to find my value of sigma. So back to my old faithful little calculator here. Again, which calculator you use is entirely up to you. Because both of these are negative, and I know a negative divided by a negative is a positive, I'm going to disregard the signs and just do 3 divided by 2.3263. And my answer, which again, I'm going to write in full, 1.2896. But if we want to give to 3 significant figures, is going to be 1.29, and I'll double underline that at the bottom of the page. I'll have a very quick check through, but that concludes question 2.